Algebra 1, Lesson 56. Whoop. Finite and infinite sets, membership in a set, and rearranging before graphing. So, a number set is quite simply just a group of numbers that are set aside for whatever purpose that the user has for them. But it's very important that we learn how to notate sets. And there's two differences as far as number sets. You have finite sets, finite meaning there is a definite beginning and end, or there's a definite limit. We understand what the beginning and end is. For example, this is a number set. It's got 5 numbers within the set. And it's finite because we know exactly what all the members of the set are. It's got a definite beginning, a definite end. Now, an infinite number set would be like this set right here. This is the set of counting numbers. And as you know, we can count from 1 to infinity. We'll never stop. So the set of counting numbers is an infinite set, and that's shown by these ellipses right here, the period, period, period. So to make a set, you're going to draw a brace at the beginning and end. And if your set is finite, you will put the end of brace after the last number. If it is infinite, you'll put a comma once the series has been established, period, 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 and then you will put the ending brace. So that's the difference between finite and infinite sets. Now let's talk about set membership. So let's say we have this group of numbers right here. We've got 0s, 1s, and 2s. Now, when we designate a set, let's say these numbers are in a group and they want you to write them as a set, and they want you to name them as set B, which is what the book is doing. In a set, we're never going to list one number more than once. So even though the number 0 shows up 6 times, when they draw the set B, they're going to put B equals 0, 1, 2, end set. Excuse me. And the reason why is because in a set, we never repeat a number, even if it shows up multiple times in the group. And we see that with the 0, the 1, and the 2. And then the way we would designate it as set B is we would just write B equals the set of 0, 1, 2. Let me see here. So that's pretty much how that works. They'll give you example problems like this. 56.1, they give you a group of numbers and they want you to represent them as the set of k. You'll just write k equals 0. Right? We see the number 0, and then we see the number 1, then 2. There's no 3s, so then I go to the next number, which is 4. Then I write down 4. There is a 5, and then I've got 2 7s, but I write down 1 7. So set notation is pretty simple. Now let's see how we can pull information from a set. So we have to learn this, here I'll draw it here. We have this funny looking pitchfork symbol that looks like this. All right, it's kind of like an E. That's actually not a good drawing, hold on. The symbol looks like that. It's kind of like a pitchfork. So if I had this written down right here, what this symbol is saying is that 5 is included in the set of A. And that's all that symbol means. It's just saying that 5 is a part of A. Now, what if I did the opposite? What if I did this and I put a line through it? Well, that's the exact opposite. That's read as 5 is not a member of the set of A. And the only thing we need to use these for is some true and false questions, like on 56.3. They give us some number sets. Oh, my camera's falling apart. Hold on. They give... Good enough. They give us some number sets. The set A is 0, 1, 3, 5, B is 0, 4, 6, 7, and set C is 1, 2, 3, 4, or 1, 2, 3, 5, and 7. And they want us to know, or they want to know if these statements are true or false. So the first statement, 5 is in the set of A. Well, if we look at set A, 5 is definitely in that set, so that's true. Statement B, 4 is in the set of C. Well, if we look at C, there is no 4, so that is false. And then statement C, 5 is not in the set of B. If we look at the set of B, there is no 5, so C is true. So that's set notation. That's how you use those problems. They're really, really simple. Now let's go to rearranging before graphing. So we'll go to our paper. So we know that in order to graph an equation, we have to have it in the form of y equals mx plus b, right? M is equal to our slope, and b is equal to what we call our y-intercept. And in order for any equation to be graphed, or any linear equation, it has to be solved for y. Y cannot have a coefficient, and it cannot be negative. Now the problem is, they're going to give you problems now that say to graph equations like this. No, whoops, that's a 4. They tell you to graph 3x plus 2y equals 4. Now if we look very quickly, y does have a coefficient. It's not all by itself, and we're not in the mx plus b format. So this cannot be graphed yet. What we have to do is rewrite the equation. So we're going to use our rules of algebra to move some things around. First thing, since we're using PEMDAS backwards, I'm going to move this positive 3x. I will move it through subtraction. So I will subtract it from each side. That side will cancel, and then what I get is 2y equals negative 3x plus 4. Where did the plus come from? Well, this 4 is positive. Why did I put the x in front instead of at the end? Because I want to get it in this format. I want to get it in y equals mx plus b form, or slope-intercept form. Now, I'm not done though, because I still have this 2 next to the y. So I'll go ahead and divide by 2. Now, on this right side, in order to make this easy, I'm going to divide each piece of the polynomial by 2. That makes it very easy to get it in y equals mx plus b form. Because what we see here is negative 3 over 2, that can't reduce. However, 4 over 2 can reduce. So if I write it as 2 separate fractions, it helps me get to this form easier. And I'm not breaking any rules of algebra by doing this. So I can write this as y equals negative 3 halves times x. That would be our mx, right? And then 4 over 2 equals 2. So I'll just put plus 2. And that is our b. Now I can graph this line. I can go ahead and use an x and y table. I can plug in 2, 0, negative 2. And again, I'm picking my denominator of my slope so that way I can get whole numbers. And then I'll start solving. If I plug in 2 for x, I end up getting negative 3 plus 2, which is negative 1. So y will equal negative 1. If I plug in 0, y will just become positive 2. If I plug in negative 2, that's going to become positive 3 plus 2, which makes y 5. So now that I've got 1, 2, 3 points, I can go ahead and graph this line. Whoop. So I'll pull out my coordinate plane. And then I'll graph these 3 points. Oop. So I can get my line. Oh, that's the wrong marker. Where's my good marker? I'll use this one. Okay. So the first point, 2, negative 1. I go over 1, 2, negative 1. That's point number 1. Then 0, 2. So starting at 0, up 2. That's point 2. And then negative 2, 5. Negative 1, 2. Up 1, 2, 3, 4, 5. That's point 3. And then I will go ahead and draw my almost straight line. There we go. Good enough. And then there's my line. So to regroup before graphing, remember, get it into y equals mx plus b form, solve the equation for y, make sure y is positive. That's all for today's lesson, and I will see you in class.